So it says like at w equals 0, it's -7. So you just plug that into the equation it gives you, and then you just do y plus 7 equals -7 in parentheses x minus 0. And then you figure out that the equation is just -7x minus 7. And then you plug in 1 into the x and you get -14.
Good. Now, before I got to your group, how did you start this? What were some of the things that you were thinking that you might have to do?
I went straight to that like exponentiating. I forget what it's called, but I started doing it. And they were all like, "All right, I'm done." And I was still like working on it. I was like, am I slow at this? Am I doing something wrong?" But they
No,
told
but
me that they just plugged it in real quick. I made it harder than it had to be.
so talk me through that. What are they asking for here that after we're doing all these differential equation problems, we just assume they're asking?
Tangent line.
They're asking for the tangent line. Good. Is that different from solving that differential equation?
Yes.
Yeah, tell me what you get when you solve the differential equation.
The slope.
When you solve
Oh
a
wait, no.
differential equation, what do we get? Are we sure it's the slope? What are we looking for when we solve a differential equation?
Well, are you asking like what we get when we get that like just normal y equals equation? Is that
Yes.
what we come up with?
If you would solve that how you started, David, and you solved it for W, what would you be
Right.
getting?
Would you just be getting your original equation
Your
of the
original
line?
equation. Yeah, is it always a line?
Or of whatever is of the graph.
Good. So it's just any curve, right? It's the solution. And remember, we can see that solution where? What else can we tie this to that we've done that we can actually see the solution to that differential equation?
Those for the slope field thingies.
Yes, the slope field. Yeah,
Oh,
exactly. See how it's all tied in. But then this question threw a total curveball, and it didn't ask you to find the solution to the differential equation. It asked you to find the equation of the
tangent
tangent
line.
line, right? Could we have done this back in chapter 2 when we did derivatives? Yes, so this is a chapter 2 problem, but what did they do to throw us off a little bit?
They gave us the derivative.
Yes, and how did they write that derivative?
dw dt.
dw dt. What if they had written instead w prime? Do you think
Oh
you
no,
would have?
yeah, I wouldn't have gone the route I went in the
Yeah,
beginning. You said W prime.
good, good, good. So do you see the difference? David was solving the differential equation. No, could you have still done that?
I mean, I'm sure you probably.
Where does the tangent line come in then? If he solved that differential equation and you guys got the tangent line, put the two together. What would happen?
Um,
If he solved that differential equation, he went through and he got the equation for W, and you guys got the equation for the tangent line, how do they compare to each other? They weren't looking for us to find W equals in this one, but just since you started it that way, what's the relationship?
well, if I had the original and they had the tangent line, wouldn't it just be the derivative of my equation?
The derivative would be the slope, right, of your
Yeah.
curve where? At what point?
Would it just be that specific point they gave
A
us in the
specific
problem?
point, yeah. So you basically found the equation of the tangent line to that curve at that specific point. Okay, now who's your recorder? Who's
Uh,
gonna talk to us about it when we come back to the group? We'll decide because we want to see your work Okay, so you guys decide. I'm going to leave you. And what I want you to do is to work a little bit on A, C, and D, or at least read them so that when they're presented, you'll at least know what they were on. Okay, so give you a few minutes. All right, and then we'll bring you back together.
Okay.
Okay, good job, guys.
Thanks.